Hello, Gavin.
Hi,
How are you?
I'm good. How are you?
Oh, I'm excited about today.
That's good.
Hello, Hannah.
Hello.
The other Hannah, like back to back, at least on my screen, show up. That's pretty cool.
Hey, Mr. Kruger,
Yeah.
for MHS hours, is there somewhere where you turn them in like on Schoology, or do you just want us to email them to you?
Just email them to me, but
Perfect.
I don't. I thought email would just be easy, just taking a picture and sending it to me. Isn't that? I'm trying to be as. I almost said low tech. I don't know if it's even considered low tech. Just like low effort on my part. So anyway, does that work for you?
Yeah, perfectly. Thank you.
I have an app called, because our computer is in repair. It may need a new hard drive, or we may end up getting a new computer. I don't know. And so I have an app on my phone called Cam Scanner, which means I can take a picture and I'll save it as a PDF, and it cleans it all up and lines it up the way I want it to do it. It's a nice little handy dandy deal. But that's how I do a lot of stuff. I just take a picture of it or scan it on my phone, send it in.
Ellie,
Yeah.
I saw on that Instagram account you're majoring in astrophysics.
Yes.
I think that's really cool.
Thank you.
That's sick.
Should be a good time.
Well, I have a friend that goes to the U of M now who's majoring in astrophysics, and he really likes it. But it's a lot of calculus stuff.
Yeah.
Oh yeah, you know who else is in it? He was in BC Calc last year. Tall soccer.
Paul
Oh,
Katsera.
Katsura.
Yeah,
Yeah, that's who I was talking about.
yeah. I saw him.
That's so cool.
Yeah, before they closed the wall. Yeah, he said he's really enjoying it. He was really
Yeah.
positive, felt really prepared for it. And yeah, I mean, astrophysics. There was one time. This is before I taught BC Calc. Somebody's missing here.
Aaron.
Erin, okay. Oh yeah, she told me. Was it today or tomorrow? Yeah, I think she told me she wasn't going to be here. Where there was a guy who had graduated. He was a PhD who was giving a talk at St. Cloud State, and he was a theoretical astrophysicist. And we had a snowstorm that night. And I thought, and I got there just so on time. And I thought, well, no one will be in there. It was at Stewart Hall. And I had opened up that if any of you guys showed up and saw me afterwards, I'd give you an extra credit point. And went in there, and it was packed. It was every seat, and I found a seat, and the guy was just great. He was, and he had written several books on astrophysics, and he was in charge of. Do you guys know what a collider is, where they take atoms and collide them together? Do you know what I mean with that? He was in charge of the one in the United States and was helping build the one that they found, the Bozeman, which they found a couple of years ago. Do you guys recall that at all? They found the Bozeman particle and stuff like that. So it's these particles that pass through you. And anyway, they found something that through this collider, and he was helping develop that. So I mean, he's like the top 10 of astrophysicists in the world. He had graduated from St. Cloud State as an undergrad, went to Wisconsin, University of Wisconsin, got his master's degree and his PhD in astrophysics from there. Okay. What was really cool, he graduated from Cold Spring.
Wow.
And so I went to Mrs. Tambo, who lived in Cold Spring. Her kids went there. And I said, so do you know this gentleman? Never heard of him. How can you not know that your high school produced an astrophysics at the top 10 in the world of this cool stuff like that? So you guys know who Rod is?
Rod Fuchs.
Yeah. He was like, his brother, the astrophysicist's brother, was in his graduating class because uh, Rod is from Cold Spring. That's where he graduated from. And this gentleman he says, oh yeah, I know him. He was a couple years older than me, blah, 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 blah. I'm going, wow, how can you not know that? I think that would be the biggest deal. Maybe somebody from Sauk Rapids is an astrophysicist. I don't know. I know there's an author from my hometown, Plainview. Well, there was. He's passed away now, and he actually wrote a book about Plainview. His name's John. I'll have to think about it, but it's Grand Opening is the book he wrote, and it's about Plainview. So anyway, got way, 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 way off topic. We're supposed to be talking about calculus, and I went to the year 2019, and I found a problem. It was the last problem on last year's test. So I'm going to share that with you, and we're going to walk through this baby, okay? You know what? I was so excited. I got up at 4:45 because of this problem. So we'll see. And so, you know how much coffee?
John Hassler.
John Hassler. Yep. Thank you. And so John Hassler was babysat by, listen to this. He was babysat. John Hassler's parents ran the grocery store in town.
Mhm.
And his parents was my mother-in-law's parents' best friends. So my mother-in-law babysat him. My mother-in-law is 90 now, okay?
That's cool.
And he ended up getting Parkinson's disease and dying from it. And he was a professor for a while at St. John's, and St. John's is a retirement center. My son took care of him at the retirement center. So that's kind of, yeah. That's pretty cool.
That is cool.
Yeah, they used to have a theater in Plainview called the John Hassler Theater, but people don't go to theater in Plainview. It's kind of sad. So, what can you say? Alrighty, now that's out there in the abyss, I'll get a whole bunch of angry hate mail from people in Plainview. Alrighty, I'm going to share this with you. Brady, do you see this?
Yeah.
Okay, good. So what we have here is we have a function f. So this thing right here is f. And we have a tangent line to f, and I think it's tangent at the point 0, 3. It looks pretty correct. So it says a function f has derivatives of all orders for real numbers x. A portion of the graph of f is shown above, along with the line tangent to the graph at x equals 0. Selected derivatives of f at x equals 0 are given in the table. So this is n, so this means the second derivative is 3. The third derivative is a negative 23 halves. And the fourth derivative is 54. And it wants to write a third degree Taylor polynomial for f about x equals 0. So x minus 0, this means this is c. So if I have x minus 0, obviously I'm going to get x. All right? So I want a third degree Taylor's polynomial. And is the sun bothering you, Brady?
It's not too bad.
It's bothering me. I'm not used to it. But when I close it, I feel like I'm in a dungeon. All righty. So how do we start this? What's our first term?
Is it f of c?
Yeah,
So-
and c is 0, so it's f of 0, correct?
Yes.
Do we know f of 0?
You just look in the graph.
Yeah, I think so. What is
Yeah.
it?
3.
3, perfect. Okay, so now it's going to be plus, correct?
Yep.
So the next one, now remember when I write this, this next one is going to be the first derivative at c, correct?
Yep.
right? It's going to be the first derivative at c times x minus c to the first divided by 1 factorial, correct?
Yeah.
And since c is 0, it's going to be x, correct? But I need to know
Yep.
what the first derivative is. And they don't tell me that. They tell me the second derivative, the third derivative, and the fourth derivative. Do you know the first derivative? At
No.
x equals 0. Yeah, you kind of
Right.
do, and they're sneaky about it.
Is it -2?
How did you get a -2? I believe it is.
Oh, it. It's like
-2 is
the
correct. How'd you get a -2?
oh, it's a slope.
The slope of the what?
The tangent line.
Perfect. Perfect. Yeah. Here, down 2 over 1, down 2 over 1, a -2. So I could write -2 here, correct?
Yes.
Okay. So here's f of 0. Here's our first derivative. Our second derivative is what?
3
Plus 3
plus
x
3x
squared
over 2.
over 2.
Oh, x squared over 2. Yeah.
Yeah. These two always have to match up. That's 2 factorial, which is 2.
Yeah.
And this is the derivative, correct?
Yes.
All right, perfect. So 3 minus 2x plus 3x squared, we want a cubic, so we have one more we got to go, correct?
Yep.
All right, so what are we going to have?
Minus 23x cubed
Yeah.
over 12.
Yeah, I think so, because you have 2 times 3 factorial. It is 12.
Yeah.
Perfect. Awesome. Awesome. Very good. And are we supposed to do anything else with that? No. Right?
Right.
We got it. All righty. It says, write the first 3 non-zero terms of the Maclaurin series for e to the x. And then it says, write the secondary Taylor polynomial for e to the x f of x about x equals 0. So we have 2 tasks here, Kyle.
So you start off by writing the e to the x ones, which is 1 plus
Okay, can
x.
I write e to the x is approximately,
Yeah, 1 plus x squared over 2.
it's nice, isn't it? Okay. What about secondary polynomial for this?
So wouldn't you just like multiply the first 3 terms from part A times the first 3 terms from part B, right?
Yeah, perfect. So it's going to be,
Do you have to like multiply it out? Like, or do you have to FOIL?
well, it says write the second degree Taylor polynomial. So this is a second
So yes,
degree. This is a second degree. I don't think so.
you don't? Okay.
No. So I think we just have to do this. Taylor polynomial. And so tell me what to write.
Okay, so parentheses 3 plus 2x.
Or 3 minus 2x. Sorry, that's
Oh yeah, okay. Plus 3x squared over 2. And then times the quantity 1 plus x squared over 2.
Yeah, and I wouldn't multiply that out. I don't see any benefit to do that. My guess is
Okay, good.
if I looked at the key right now, the key would say, oh, guess what? They did multiply it out. You gotta be kidding me. Really?
Would you be expected to?
Oh, let me look at this. Yeah, I think so. But I think there's an easier way to do that. And I'm just looking at what they're showing me, okay? Well, let's multiply it out.
All right.
And you tell me what we get here.
Okay, so it's 3. I'm just gonna like do every single term. So
Yep.
3 plus 3x plus 3x squared over 2
Okay.
minus 2x minus 2x squared minus x cubed, right?
Okay.
And then plus 3x squared over 2
Okay.
plus 3x cubed over 2 plus 3x to the 4th over 4.
Alrighty. So we got 3, correct?
Yep,
3x minus 2x.
is x.
3x squared plus 3x squared.
And there's a negative 2x squared as well.
Right. And there's a
So
negative.
it's just negative 2x squared. Oh no, never mind. It's not subtracting it out. So that'd be just a regular x squared.
Right.
And then x cubed over 2
Yeah, x cubed over 2.
plus 3x to the 4th over 4.
Alrighty. That is not correct.
Yikes.
And so what I need to do is, they said this.
Are any of those terms correct?
The 3 and the x squared are. They drop these 2. Oh, because I think it's a second degree.
Oh, you just need second degree.
Yeah, that's why.
So then you cut off anything that's just bigger.
Correct. That's why. Does that make sense?
So really, we could have just found the first 2 terms of the first 2 and multiplied them together.
Correct. We could have saved ourselves a lot of work if we thought about that. Okay? I'm going, well, why isn't that? Because these did everything correct. Well, yeah, because now we went to a 4-degree polynomial. Okay?
Gotcha.
Okay. All right. Sorry about that, everybody. All righty. So let's take a look at this. Yeah, we could have said, okay, we got this, and we got this, correct? And then we have a minus 2x times here, a minus 2x from here, and then we would have been done, right, Kyle? And we could have forgotten. Oh, then we would have had to have this one.
Well, yeah, you just wouldn't write down anything with an exponent of 3 or more.
You're right. Correct. All righty. Okay, very good. Gavin, let h be this function. H of x is equal to the integral from 0 to x of f of t dt. Use the Taylor polynomial found in A, thank you, Brady, to find the approximation for h of 1.
Okay. So you're going to have like the integral from 0 to 1
Okay.
of, I'm assuming, the thing in A, right?
Right. So this is, it says use the Taylor polynomial. So this would go into here, correct? Because this is an approximation using the first, using a third degree polynomial, correct?
Yeah.
Okay. So what are you going to want to do here?
So you have to take the
Integrate from 0
antiderivative.
to 1, right?
Yeah.
Of,
Oh yeah. Sorry. Of 3 plus 2x.
minus 2x. That's my fault.
Oh yeah, minus 2x plus 3 over 2x squared minus 23 over 12x cubed. And then you get 3x minus half x squared.
I think you just get x squared.
Oh yeah, I
Okay.
don't know what I'm doing. Minus x squared plus I don't know why it's taking me so long to figure this out.
Because it's morning time.
Is it eight, 9?
It's 1/2 x cubed.
You're going to divide by 3 or multiply by a third, correct? Right?
Oh yeah, I was doing 6 for some reason.
Yeah. So that's 1/2 x squared. And then this is going to be minus what? This is going to be 23 x to the 4th over what? Gavin.
3.
Well, you're going to
48.
multiply by 4, aren't you? It's going to be 48, isn't it?
Because you
Oh yeah,
the 4's
times-
on the bottom.
Yeah.
Yeah.
I get it.
Now, what they were nice is they put 0 in here, so I don't have to compute 0, and they put 1 in here, correct?
Yep.
So my answer is going to be 3 minus 1 plus a half.
Wait, why do you put 1 in?
Because it says
No, h of 1.
1.
And
Oh,
it's 1.
gotcha.
Okay. Minus 23/48. That's awful.
Yeah. So
You must have a machine close by, don't you?
Well, that's like almost a half. Like almost.
This is
So-
almost half, correct?
Yeah. So it'd be 2 and 1/48, right?
2 and 1/48,
Yeah.
or 97 over 48.
yeah, I got that. I got 97 over 48.
Yeah.
All right, good. All righty. What did you think of those 3 for problems? A, B, and C. Not too out of whack.
No, they're doable.
They're doable, right?
You can figure out how to divide a fraction.
Okay, so it is known, this one's a little tougher. Right, I mean,
Right.
even if, once you get to here, you would have got 1 point. So this was worth 2 points. This was worth 2 points. This was worth 2 points. Okay, and I should write down what the right answer was here. And it was 3 plus x squared. All right. It is known that a Maclaurin series. All right, Jonathan, what does that mean? As soon as I say it is known that the Maclaurin series. Maybe he's not here. Let me pick Ellie. I say it is known that the Maclaurin series. What's that telling you?
I think she left too.
Really?
Her screen's blank.
How many people are here? I'm gonna get sad really quick.
Everybody but those 2.
Ryan Zaski. It is known that the Maclaurin series. What is that telling you?
Like C = 0.
Right. So I'm going to write that down, okay? Because I have a tendency to forget. converges to h of x for all real numbers. Okay, so this series and h of x match up perfectly for everything. So that not only is it a good estimate, it's the best estimate because it matches all along. It is known that the individual terms for h of 1 alternate in sign and decrease in absolute value to 0. So notice here we had h of 1, right? And they alternate, correct?
Yep.
Okay. So what they are is you can view it as an alternate series. Okay. You know, 3 minus 2 plus 3 halves minus 23 twelfths and so on. And so in decrease in absolute value to 0. So what they're saying is they are an alternate series because those are the two things you need to know. You need to know that they decrease to 0. Okay. Use the alternate series error bound to show that the approximation found in C, which is this, differs from the real h of 1 by at most 0.45. So let's take a look at this. My question is, if this is my series, and I'm going to write down the series, it's 3 minus 2 plus 3 halves minus 23 twelfths
Wait, where are you getting this?
I wrote said 23 24ths and I want 23 twelfths. So I'm saying when x is 1, didn't we have those terms?
Yeah.
3 minus 2, 3 halves, and 23 twelfths, correct? What would be the next term?
So you need to go to the thing at the top.
Okay. Right here.
Yeah.
Okay.
So it would be, you have to take the antiderivative of,
No, it'd just be 54x to the fourth
okay.
over 4 factorial, right?
The next one would be,
But then don't you have to take the derivative or the antiderivative of that? Oh, never mind. What am I talking about? Wait. Yeah, I don't know. I'm lost.
well, no, I think you're right. You're looking at that the next,
Yeah, you
uh,
just
I
need
was
to
looking
make
at
sure that the next term is below like 9/20ths or 0.45.
correct. So in other words, the next term here, if we would continue with what Brady had, would be 54 is our derivative, correct?
Yeah.
The x to the fourth, and this one would be divided by
4
4
factorial.
factorial, correct?
Yeah.
Right? And
Yep.
so x is 1. The next one I would add is 54 over 4 factorial, which is what, 24, correct?
Mhm.
Yes.
So we have to show,
So it'd be 9/4, right? Because you have to simplify it. That doesn't seem right though, because that's
no, and I think we're going to go back. I think Gavin's right in that the series that we're talking about isn't this one. It's this one right here, the antiderivative, correct?
Yeah.
The antiderivative that's decreasing. Am I right?
Yeah.
Yeah,
So
this is
it's
going to be 3 minus 1 plus a half.
Yeah, because you're using h of s.
so it's
and
54
that's
over
the inside
96,
derivative.
right?
Correct. So this is 48. So our next term would be what?
54 over 96.
Plus 54 over 96. Correct. Right? Because you would, this would be x to the fourth, correct?
Yeah.
Right? And
Wouldn't you multiply it by 1/5? So it couldn't be
right,
90.
150,
Oh,
not
whoops.
96.
Sorry.
Be 120, correct?
Yeah.
Yeah, 120.
Okay. And so here's my alternating series. It started at 3 minus 1, 1/2, a negative 23/48. And so this is the term that I have to take a look at, correct? And I have to show, I'm going to cross.
Can you scoot it down? Or scoot it?
This is wrong, so I cross that out. So this sum,
It's 54, by the way, not 56.
this 97 or 48 came from those four terms, correct? Would
Yeah.
everybody agree with that?
Yeah.
So next term, we know the error is got to be less than this next term. This sum is pretty close to the true sum, and it's saying, hey, you got to make it from being the true sum, it has to be at most, it's not going to be more than 45 hundredths, correct? In other words, the true s minus s of 3 is going to be less than or equal to the fourth term. And if I take 54 and divide it by 120, what do I get on your calculators?
You get 0.45.
0.45. Exactly?
Yep.
All right. So we know, and this is the remainder, correct? This is equal to the absolute value of the remainder. The remaining the remaining terms after the first three are added. And so we've just shown that's less than or equal to 0.45. That one's a little heady. So when Gavin, you were correct when you were saying, hey, these are the ones we got to look at. I should have dismissed this right away because these terms had to be decreasing and they're not here. Okay.
Okay.
All right. So tomorrow, I'm just going to open up I'm just going to schedule a class and you can come in if you have any questions. Okay. And I have an assignment that's due tomorrow. So if you have some questions on that assignment, you can ask. And I have another assignment that is due on Monday. And if you have any questions about those, you can ask also. Okay.
Sounds good.
Okay. Does anybody have any questions on this or anything else for the class? Oh, I got some information to share with you. Shoot it. So they had a webinar for the teachers of AB and BC calculus. And I have some information to share with you. First of all, the test, you'll have two questions. One which is 25 minutes and the other is 15 minutes. They will have a timer on your computer. So you'll gain access. You do not need to download a secure browser. You will be going to their server. And you will type something in to make that connection. And you can print out the questions and work with them, or you can enter them, take a picture of your work and download it, or however you want to download it. You can even type them out and download them if you wish. When your 25 minutes is up, you will have 5 minutes to download. You will not be able to go back to the first question once you download. If you don't download in those 5 minutes, your question will be scored as a 0. Now, there is a procedure where if something happens where The internet goes kaput. There are additional test dates that will be open for you to take it again. Does everybody understand that? Okay. Then on the second question, you'll have 15 minutes and then another 5 minutes to download your answers for that. You don't need a calculator. It will all be basic arithmetic, but you can have any calculator you wish, online or offline. So if you want to use Desmos, you could. All right. But the questions are such that you don't need a calculator. There will be no AB sub score. You're only going to get a BC score.
So if you don't like the questions, you can just shut off your router and then take it another day.
I don't know. Okay. I don't know.
Okay.
This is what they said. Someone's already tried to attempt to cheat to get in the physics test, and they know about it. And they said, ask your students their experience afterwards. I think that, I've had to go to Spectrum sometimes and ask them questions. And as soon as I log into Spectrum, they can see everything that's on my computer. And my son Sam worked for a company in the cities, a company that helped manage insurance, and he dealt with health insurance. He said when the people came and logged onto his site, he was the complaint person. So if you had complaints about your insurance, he could see on their computer that they were lying, because they would tell him, I didn't receive an email, and he'd go right to their email list into where they deleted, and was able to pull it out and show the person, no, it's right here. You got this, because they hadn't paid for their health insurance. And I think that's kind of the way it is with the calculus, the College Board. They said, oh yeah, we'll know right away whether they're cheating. We'll know right away whether somebody walks into their room.
Really?
Yeah. I'm going, how are they going to know that? They said, oh yeah, we work with the government.
They probably have
Access.
they probably have your computer camera on.
Yeah, and audio.
Yeah, I think so too. They said, oh yeah, we'll be surprised. And then the other thing is if we catch anyone cheating, obviously they don't get scored, but we let the colleges and universities know that this person has cheated on an AP exam. And it used to be, and I don't know if it's the case, when I was in college, I took a econ class, and you would take your test in an auditorium, and you had to be separated by so many seats from every single person. And then they would patrol up and down to see if you were cheating. And Buzz Johnson was the name of the teacher. And he caught a guy cheating. And Buzz Johnson was a big professor. He was huge. He played football at Stanford. Grabbed the guy from the back of the shirt, yanked him out of the row, threw him out of the auditorium, and says, you are done going to any state college or university in Minnesota. And I know people in Wisconsin, and I know people in North Dakota, and I'm writing letters to all of them. You are done in the tri-state area of going to college.
Yeah.
And we just went like this, God, it scared the crap out of us. But so anyway, I'm supposed to tell you that, warn you about that.
But we can use notes though, right? Isn't it like
notes? You can use your book. You can't use each other. You can't use the abyss. Yeah.
Speaking of books, I still have this.
Oh, good.
What do I do with it?
Well,
if I can't go back to school, should I just give it to my little brother to give to you?
You just keep it.
I keep it till after May 12th.
Okay.
Because, there's some nice formulas there at the beginning of the pages that are in blue, right?
Oh, yeah.
Yeah. So, I mean, you can use it.
Use this?
Yeah. That's what we're just talking about.
Cool.
So, yeah, let's worry about what happens in May.
Okay.
Who knows? Miracle. We might be all back together having lemon bars. Who knows?
Oh,
First day back to school.
There was a sale at Coburn's on lemons, and I bought them. So there's a bag of 15 lemons in my refrigerator from before March 17th. And there are, I don't know, 20 boxes or 20, not boxes, but she's got all the ingredients for lemon bars. And so she's very anxious to make them and distribute them for you guys. But anyway, that's kind of where it's at. So tomorrow will just be kind of an open session, and you can just come in and ask some questions if you need to. Okay?
Okay.
All right. And then Monday, I think I've got the majority of things I need to talk about that's new. I need to just examine a couple of things to make sure I'm not forgetting something. So there might be notes on Monday. I would say there's probably, knowing me, a 75% chance that there'll be some notes on Monday. There are some things I just want to fix up. Okay? Okay, it's supposed to be a great weekend. Enjoy.
Bye.
adios.